Okay. My camera settings look like they got botched. So let me adjust that quick. Which is weird because they should be the same. Let's see here. How do I get Elgato? Elgato camera hub. All right, 1 second. I'm gonna throw on a hat because my hair looks greasy AF. Even though it's not. Literally just showered earlier. Alright. This like reset my camera settings, which is really annoying. Go there. And then let's see here. What do we think? Something like I forget how to set this up. Is there any camera lag? No, that looks good. This actually looks decent. All right, we'll rock with that. Okay, so we are playing around with writing a Lexer. Beer on a school night? Yeah, I know. It's getting rough out there.
Shit.
We are working on implementing the Lexer from Thorsten Bell, I forget his name, book. And we are working on writing it in a more OCaml way and also partially taking inspiration from TJ's implementation, but trying to do it on our own for the most part. I mean, better to drink beer than U.S. tap water? Listen.
What's funny is in my book, it's literally about putting parasites in tap water.
Well, what are you going to do?
Slowly poisonous, but this is also...
What doesn't kill you makes you sicker.
Yeah.
So right now we are trying to Lex this input here. Yeah, we're just trying to Lex that input into tokens. And right now we're failing. And I don't know why. I want to make sure that this is actually doing like a deep structural comparison. So this should pass. And it does. Okay. So why is this not Lexing correctly? This will be advanced Lexer. No, I'm not off work. My tentative start date is going to be the 19th, and I let my current boss know that next Friday would probably be my last day. There's some small logistical things to work out yet, like payroll and shipping laptops and stuff like that. Hopefully everything gets smoothed out for the 19th, but my start date could end up being the 25th. Yeah, I'm going to be working at Vercel. He's a TypeScript guru now. Yeah, something like that. Can you fix me a promo code? Something like that, Priv. Thank you. Thank you, y'all. You put in a CFP for ATO yet? What is ATO? I've never even heard of All Things Open duct tape. So I'm going to be working on the lifecycle team. So essentially owning a bunch of the tooling and workflow from like account creation to account management and that kind of world. Raleigh Open Source Conference. Oh no! Is there a CFP site up, duct tape? Yeah, it'll be all remote. It'll be mostly TypeScript with some potential for Go and Rust. Cool. I'll keep my eyes open for that CFP. Is it like polyglot? Like I can submit a talk on anything? Cool, yeah, I appreciate that. I will forget, to be honest. Okay, so this isn't doing what I expect. We should say list.length of tokens is 2. What? Negate add. That should be right. We hit a plus. I wonder if it's doing something stupid like nice. But a Vercel employee is now following me. I feel really cool. Something like that, Priv. You're the one implementing sweet DB stuff. We should say list is at or nth. There we go. List.nth 1 equals add. What is that? Takes the list first, sure. Tokens. So this should pass. It does not. What if we do 0 and say negate? That fails as well. Maybe we say something like let first token equals list.nth tokens 0. Guess we could just said head, right? In, and then we can say token dot equal first token and then negate. Does that pass? That doesn't pass. Oh, I bet the tokens are in reverse order. Yeah, the tokens are in reverse order. Ha Right. Okay. So, your stream is annoyingly clearer than others. When you say clear, do you mean my video, my audio? Yeah, my video or my audio? When did Vercel start hiring models? Listen, y'all. I've said before, my ego does not need any more stroking. As Justine is cackling.
I'm sorry.
Yeah, I just noticed I'm peaking. Test, 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 test. It's a little bit better. Hey, I've only been in Raleigh for a little bit.
Can I finish my book, please? I have one chapter left.
Chats have now that I work at Vercel, we have to hire a rice cooker.
What the fuck? The worst part is that happened months ago.
Test, test. Man, I'm still peaking on my mic. It's a little bit better. Hopefully my mic's a little bit better.
Buddy, stop. I have less than 10 pages left. Let me read my book. Please. Please. I know you're a good boy. But give me 10 minutes. Just 10 minutes.
There we go. Okay, so this should work now. There we go. Okay, so we should be able to uncomment that. That test should hopefully pass now. Yeah, there we go. And then if we uncomment that, and now expected should equal tokens, and we can delete that line, uncomment out that line, run our test again. Boom. Okay, so we successfully lexed this input to tokens. Thank you for the sub, Duct Tape. Super appreciate you. Night, Priv. I'll catch you in the morning. I'll be streaming in the morning as long as the contractors aren't coming in the morning. Are they coming tomorrow?
I don't know.
As long as the contractors aren't here in the morning, I'll be streaming. Actually, I might have a dentist appointment. My dentist appointment tomorrow isn't till... What time is it? It's at 10. So I have to leave at 9:30. I can still stream. Yeah, I'll stream tomorrow as long as the contractors aren't coming. See you, Priv. Have a good night. Okay, we can delete that. And then we can say... We can pipe this to second, and then we can pipe that to list.rev, and then we can delete these two lines. Boom. Great. That should still pass. Perfect. Yeah, my GitHub's personal. Okay, so that looks good. We can advance through that. So the language we're trying to parse is a tiny little programming language that is in the first chapter of the book we're doing in the Caravans book club called The Essentials of Compilation. And it is called rint, and it's a really, really simple language. The grammar of rint looks something like this. Let me pull up the book. Oh, I need to fix my screen here. Properties, show cursor, switch my screen over to there. Whoops, not that one. There, properties, back to my other monitor. And now show cursor, and the lag's gone. Still no clue why that works. Very weird, but whatever. Did I close that tab? Right. So this is TJ's implementation of the Lexer from Thorsten's book. Sorry about the white screen, y'all. Just gonna have to deal with it. I don't even think Dark Reader will work on this. I mean, technically it will, but it doesn't really
That looks terrible.
do anything too great.
Ew. Change back.
So here's the grammar of our language, right? It's really simple. So we have this expression, which can be an int, a read operation, a negation of another expression, or a addition of two expressions. And then the entire language is just rint is an expression. And formally, we have this other like program word. Okay. What the heck? This is still lagging. Normally that fixes things. Oh, I forgot to do this step. Dumb. Hold on, chat. I'm sorry. All right, we should be back. Yeah, there we go. And the lag's gone. So we have this simple grammar, and we're trying to just parse it into, we're trying to lex and parse it into our AST, and then we have a interpreter and a optimizer written from the first chapter. And the optimizer is a partial evaluator. The book is called Essentials of Compilation. Let me drop the link in. It's free. So the book assumes you're using Racket, but I'm doing it in OCaml. My goal is by the end of the book to have a full like Lexer, parser, optimizer, and compiler for Racket written in OCaml. But like the first language we make is this one called rint, and right here is the entire programming language. It's really simple. OCaml is a general purpose functional programming language. Okay, so we need to be able to parse really all of these things here. So we need a way to parse identifiers and keywords. So like our program is a keyword. Let's see here. Yeah, our only real identifier, I think, is program. What up, Ninja? I appreciate the 4 months of subs. Really appreciate you, man. No, Kyle. I've been streaming since the last week of September. Ninja, tonight we're just playing around with trying to write a Lexer based on Thorsten Ball's book, Writing an Interpreter in Go. And we're also partially taking inspiration from TJ's implementation of this. The intent is to have a parser and Lexer to complement the compilers we write for the book we're doing in our book club in the Discord. So right now we're just trying to write a small Lexer for the grammar of the language we wrote in the first chapter, which is called rint, which the entire grammar is right here. Like this is the entire programming language. So pretty lightweight, but I've never written a Lexer or a parser before, and only yesterday did I write my first compiler. So I might try to play around with Angstrom. I've used Angstrom, which is a parser combinator in OCaml before. But right now I'm just kind of following Thorsten's book and trying to adapt it. And also stealing ideas from TJ as I go. All right, so where were we last? I think I got through all this. No, the book is interpreter book. Thorsten Ball. It's really good. Do you see the cloth I used to clean my glasses anyway?
I don't know what you ever do with it.
Weird. Whatever.
Weird.
I don't need it quite yet. Yeah, identifiers, keywords, and numbers. So we know we have a identifier. So let's go back to our tokens. Okay, yeah, we have two keywords called read and program. Yeah, that looks good, I think. Start with identifiers and keyword. What our Alexa needs to do is recognize whether the current character is a letter, and if so, it needs to read the rest of the identifier or keyword until it encounters a non-letter character. Okay, so we want like a is alpha. What up, Eduardo? Thank you for the raid. Appreciate you. If y'all don't follow Eduardo, you should, because you're going to know about the language he's working on in a few short years called Teika. As soon as Teika is in some sort of usable state in beta, I'm going to start shilling it.
Do you want another?
Please.
I finished my book. No comment?
What?
I finished my book.
How was it?
Oh.
What's the review out of 5?
It's probably like a 4.
4 out of 5?
Yeah.
It's pretty good.
I expected better though. This was the one that just came out last week.
Mm.
Big hype around it, and I was kind of let down.
It did make you cry.
Yeah, but most books make me cry.
Oh, okay. Thanks, Eduardo. Have a good one, man. Appreciate the raid. Why is my keybind not working for next track. Okay, so we've got our keywords.
Did you hear me?
No.
So the cake that you had on that plate
Yeah.
that you just put in, there's icing on the top of the fridge.
Oops, I'll clean it later.
I'll get it. But what the hell? Yeah.
Noons. No, they're not. The interpreter that's written in this book is for a made-up programming language called Monkey Lang. Let's see how TJ did this part. Let's see here. TJ's implementation. Thank you for the raid. Peak char. Skip white space. I do need this function. Is number. So it doesn't look like TJ has a is letter. Thank you.
I'm gonna make myself dinner and feed the dogs.
Okay.
Okay. Yeah, do you want an early dinner? Do you want an early
Where did alpha come from? Oh, do we have is alpha built in? I bet that's why he didn't need one. Do I have the standard library open? I don't. Does this have is alpha? Is that where that came from? No, that must have came from. Oh, he's using base. Right. Maybe this is worth bringing in base for. I've wanted to play with containers too. I'm gonna go look at this on OCaml. What am I looking for here? Containers. And then we want to look at string, or maybe char. So it mirrors the standard library, and then it adds extra stuff. It still doesn't have. Maybe we just do add base. So I'm not gonna make I made the mistake of during advent of code not using a standard library replacement because string stuff in the standard library leaves a lot to be desired. Codegen, pretty print, monomorphic. Yeah, I don't think this is what I want. Although it's nice that it has edit distance built in. I actually used edit distance or Levenstein distance in an interview in the past couple of weeks. Levenstein distance is a cool algorithm. All right, let's go look at base quick. I guess we can just go back, right? We can go up here and search for base. There's also batteries.
Hey. Do you think they'll be able to hear me?
No.
Are you sure?
Yes.
Okay.
Maybe, I don't know.
Well, if they do, you have to tell me so I can never do that again. Because I really gotta go, but I'm eating dinner.
Alright, let's look at, heck, we should just use base. I feel like do I even have, I probably already have base in here. Yeah, I do. Since base is already installed, we're just going to use it. Or, yeah, it's libraries, right? Base. And then we can come into Doom project and we'll just add base here. And I don't know if we'll need base there. Great. Okay, so we have base. So that should give us that is alpha function. Let's see here. We want to go back to Lexer. Now we're in here. And let's say let is, what they call it in the book? Not is alpha. Is letter. Right, so what does is letter equals, we'll get a char, and then we can say char dot, didn't I open base? No. Open base. Which, yeah, sure. Char dot is alpha, A through Z, great. In fact, we can just say, yeah, is, we can just alias that. What's up?
I just had to show you, I checked in on my senior Golden from Turkey to see like how he was doing. He's a talker and likes to give entire dissertations.
That's hilarious.
He has daily lectures.
I need shout out. I shouted you out before your bot. Scroll up a bit. It's up there. It's up there. Okay, so clearly we don't have a string dot fold left in base. String dot, what do we have? Filter map. Fold I. Do we not just have a fucking fold? Fold until, that's a useful. Do you just return a, oh yeah, you return a variant called stop. That's great. All right, fold. Okay, so this just needs to be fold. And then this needs to be, I forgot Jane Street does it like this, something like that. Fold takes a init, right? Init will be our lexer and an empty array. And then we can delete that. And then what else does this take? Init, a function that takes an accumulator, a char, yeah, that looks good. Oh shit, we got a TJ raid. Thanks for the raid, Tej. I hope you drink some warm tea and honey tonight to help with your voice. I'm sure it was a excruciatingly long day, but you did it. You got it out of the way. I'm sure all of my followers are already following you. But chat, we are working on writing a small little lexer and parser for a language called rint, which is literally just this tiny little programming language right here. And it is from the book Essentials of Compilation, which if you go and find, Essentials of Compilation is free. Teaches you how to build compilers. And I'm also coupling it with Thorsten's book, Writing an Interpreter in Go, and also using the man himself, TJ, his implementation of the lexer from that book to kind of guide my way here. So the intent is throughout the book, Essentials of Compilation, we're going to build up from basically scratch, building a compiler, optimizers, and all that stuff for Racket, so we can compile Racket code. And it starts at the AST layer. Basically, in every chapter, it gives you the ASTs rather than making you parse and lex. But I would also want to have lexers and parsers there as well, rather than using theirs, because the book is written in Racket, assuming you're using Racket to compile Racket, but I want to do it in OCaml, and that means I don't have a compiler or parser. So I'm learning how to do that. Let me catch up on chat here. Cool. Been working on Monkey Lang and OCaml. Yeah. Nice. Yeah, Thorsten's book is really good, and he's a really great author. If you're into his book, I really recommend subscribing to his newsletter too. Let me see if I can find that, because his newsletter is also, yeah, here we go. Register Spill. Highly recommend this. In particular, one of his posts, How Fast Is Your Shell, really got me thinking about my workflow, my tooling, and I ended up really trimming down the start time of my shell. My shell startup time went from roughly 900 milliseconds down to like under 75 milliseconds. So, and you can feel a dramatic difference. Let me link this this blog post too. Also, my name is also Dylan. We are the same person, Blonde Jesus. Okay, so we got to figure out, I just brought in Jane Street's base library because it's much better for working with strings. But we're getting problems where something's wrong here. So once a string is the first argument, that's probably the issue. So where's my... Okay, so we just need to pass it our input right here, hopefully, and that'll be, yeah, there we go. Great. And this will be a token list, expected equals tokens. Right, so Can we do a list dot equals AA? So we'll say expected and tokens. And let's see if our tests still pass. This expression is a type token T list, but an expression was type AA. Now that's confusing. I'm not actually doing the monkey lexer, Ryan. I'm writing a lexer for this tiny little language called rint, which is, this is the grammar for it right there. In fact, this should probably just be, now we can keep that unit. I might have to add something for unit, but we'll get there when we get there. This is the most confusing error message I think I've ever read. We have two token T lists. So it takes a function that compares an A and A. Oh, it compares two items, right? So we need, all right. So we need token dot equal. All right, so this should still get us a passing test. That's pretty good, Sienna. Okay, so we're still passing, great. So we can properly at least lex these symbols so far. So now we have isLetter. What else does char have on it? Char dot is num. Do we have is digit? Let's go. That is digit, and we'll just alias that to is digit. Great. Let's go back to Thorsten's book and keep reading. Right, we didn't do that yet. We just automatically assumed end of file as our token if it didn't match. In fact, we should do it'll be like char when we need these to go up above. We need to throw these in like here. Those are our little helper functions. And we can prevent these from being exposed with a interface file. Thank you for the follow. Wow, just like everyone. I missed a bunch of follows here. Let me scroll back as far as I can see here. Let's see. Meowwolf, Pseudo Nick, Lixlox, Volt Aberdev, Head Cookie Candlesticks, Florip, O Eugene, and Cena. Thank you, all of you, for the follows. I super appreciate each and every one of you. More than you know. When is a letter char, we say, let's just say fail with to do. Thank you for the follows, Zaka and Giraffe09. Appreciate y'all. And Willothi. Thank you, thank you, thank you. So when we read an identifier, we take the current position, and while the lexer's character is a letter, we continue to advance, and we return the slice. Okay. Mm-hmm. So we parse, or we lex, excuse me, until we've completely all right, let's see how TJ did this. Or actually, let's do a shot at doing this on our own first. So we effectively need to, when we need to start building up our identifier, right? So if we split screen and we go to our tokens, our identifiers in our int are basically some illegal thing of string, and in the file, an identifier, and int. We have two operations called add and negate. Our delimiters are left bracket, right paren, right paren. We have two keywords in our language called read and program. Program is just like the root keyword of an actual RInt program. Every program starts with a program in a S expression. So we need to be able to take one character at a time and determine if it says read or program, I think. So I think this is where like peak and oh, we do need skip white space. Let's implement skip white space. I know we need that function. So let's go up here and let's write let skip white space. And this is going to take a lexer. And we're going to have some recursive loop, right? Recursive loop. And this is going to take, what is this going to take? We almost need peak for this, but this is going to take our lexer. And we're going to say, we're going to do a match. In fact, we can get rid of this. No, we don't. No, we still need that. Well, we could loop on character, right? Equals function, and we can say change in word, and we're going to match on. Let's write a helper here. Let's move these up, throw those there, and say let is white space equals. Let's see if base has something for this. Char.is is white space. Let's go. For source locations, you would also need to start and byte positions. So yeah, we might need to do that. Right now, we're just following this book, which isn't taking into account, at least at this early chapter, bytes. We're only using characters, and we're not keeping track of the start and end positions. By the end, I imagine we'll be doing that, but we're just keeping it simple while we learn. So if we do this, when char we can say is white space. We just say advance our lexer. And otherwise, we return our lexer, right? And then we say loop lexer dot char. Oh, no, we didn't actually recurse anywhere. Duh. Expression is type T, but an expression was expected of type char. Oh, right, we should just take the lexer here. What up, Leo? Lexer dot skip loop take expect. Takes a T and a char. Oh, it shouldn't take a char. Right. That's part of our problem. Okay, that now should give us, yeah, that should advance our lexer until we hit a, yeah. Okay, so that looks decent for skip white space. Leo, would you, tomorrow's not going to be a good morning. I have a dentist appointment. How about Wednesday morning? Would Wednesday morning be a good morning for you to pair program on stream with, well, Wednesday morning, my morning. Well, I guess it's still the same day for us at that point. But Wednesday morning, my time, to pair program on Riot stuff. Yes, pair program. Sweet, cool. Let's plan on that then. I'll probably work on this tomorrow morning on stream, and then we can start tackling that on Wednesday. Just because tomorrow will be a shorter stream because of a dentist appointment, which is, I'm so tired of going to the dentist. Okay, so we got our skip white space. Actually, let's write a test for that before we keep reading Thorsten's book here. Let's say...
Hey. Sorry.
What?
Contractor just asked if we had a chance to tape areas for touch-ups.
Tell him yes, and we'll do it tonight. Or, well, tell him we're doing it tonight.
I'm just going to say yes.
Well, what if he wants to come by, like, right now? Just say we were planning on doing it here shortly after dinner.
Okay.
And we can say module struct end. We'll come in here and we'll say let percent test. We'll say it skips white space. just do something like this, and then we'll put a plus operator. And then we'll say let expected is going to be a array where we have add, and then we'll say actual is going to equal we need a lexer, so let's make our lexer. Do that, and then we pass in our lexer. And so skip white space gives us that, and then we should just have to call advance once. So let's say advance our lexer, so we can do, in fact, let's just do it the easy way. Drop down, we'll say lexer, drop down to our next line, and we'll pipe that into skip white space, and then we'll pipe our lexer into advance, and then we will say next token, and then we'll pipe that into second. Okay, so that takes a lexer and returns a lexer. Okay, advance takes a lexer and returns a lexer. Next token takes a lexer and returns a tuple. And if we take second, that's an option. We should be able to say option.get because we're in a test. So if we fail, that should be okay. Okay, Jane Street, would you? Wraps value exception. Yeah, great. Great. So now we should be able to, that's a typo, so bad. I'm rewriting Surday, and this is like the hardest thing I've built all year. Oh, snap. Well, I will tell you what, Leo. If anyone were to do it, it would be you. And it is something that the OCaml ecosystem needs because YoJSON and the two deriving variants of YoJSON are not great. We should have written that function where we exhaust. We should take this right here and we should turn this into a testing function. So let's say lex all maybe, and this will take an input, and let's paste that. And here we can say make input. Maybe we call this lex input. Maybe we should call it lex. So we'll move that, and then we'll say lex, lexer. In fact, let's just say make, say input into make into lex, and we can delete this big old block here. input into make. Takes a string that is a string. What does it think this is? A token T list. Why are you upset? Yeah, OCaml has a pretty decent macro system. The only macro system I'm really familiar with is Babel, so almost anything is better than Babel. Are you old enough for a beer? I just turned 21. Literally 3 days ago, I just turned 21, so cheers. Sus. It's very sus roasted. OCaml 5.3? When did OCaml 5.3 come out? Did OCaml 5.2 even come out? I guess OCaml 5.3 is out. When did 5.2 come out? Did they even announce this? Okay, so Leo's on the same page as me. I didn't even know 5.2 was out. I don't think there's 5.2. Yeah, there's nothing here. The most recent version should 5.1.1, I think. Yeah, OCaml 5.1. There's no 5.2. Where did 5.3 come from? Yeah, I'm even on 5.1.1. I don't know. OPAM's telling me 5.3 is a thing. Can I go to GitHub and look? The man himself, Xavier Lebeau. That's my French, by the way. I would probably be banned from OCaml forever if a OCaml core dev just heard me say that. Where's the fracking GitHub link? Shouldn't there be a repository link over here? Yeah, okay, whatever. I'm not gonna worry about that. I don't think it's picked up anything super useful anyways. I was looking for upgrades to Jane Street's base. There's a bug in Dune potentially. What is my Dune version in this list? I forget where this happened. I think I asked in Discord about this. OPAM list. Grep Dune 3.13. I think that's the most recent version. Oh no. Oh no. I will never have a job again working with OCaml in any sort of professional capacity. Now that that clip exists. I got a tentative start date today, y'all. February 19th is my tentative start date at the Triangle Company. There's a small chance it might end up being the 25th, but hopefully the 19th. All right. So there's a problem with, I think this is either a Dune bug or a Merlin bug that's reporting this wrong. I talked to, I want to say Luis Roche or somebody about this in Discord. I was hoping it was fixed by now, but Triangle Company is Vercel. I'll be working at Vercel here shortly. All right, so what does it think this is? This is a T, which is what I would expect. Now, doesn't our Lex, oh, that takes a input. Stupid. That makes sense. So we can just say Lex input in, and that should parse our entire thing out to a token T list. Let's run our tests. Let me see if I can find the job still. One second. The posting's down, but I think it's on Wayback Machine. Yeah, there we go. So this is the gig that I landed. In this role, you will be responsible for the overall development and implementation of both front-end and back-end software applications. Your responsibilities will extend to designing system architecture, high-level programming, performance testing, and system integration. Part of the lifecycle engineering team. I'm really excited to work with my new team. They are all, at least the 4 members of the team that interviewed me during the process, they were all awesome. One of the people on the team is actually on the SvelteKit core team, and I'm super excited to work with all of them. So yeah, we'll be doing Triangle Company things soon, and I'm very excited about it. Lots of TypeScript, lots of React, Next.js, maybe a little bit of Go, and maybe a little bit of Rust. Am I 21? I actually just turned 31, if you believe it or not. So we get a token there, and now we can say expected or actual equals expected. Ah, for Christ's sake. Okay, Jane Street. We say token dot equal actual and expected. And let's go Dune build and Dune run test. So we failed. We got a none. Okay, so that's not what I would have expected. I would definitely pass as 21. Good. My youth.
I'm coming to complain and then I'm gonna leave. Did you hear me?
Yeah.
I'm coming to complain, and then I'm going to leave you alone, I promise. But
You complain about me?
no.
Oh.
Why would I complain about you?
Well, I don't know.
I wouldn't do that. Oh
I
my
don't know.
God. So I pre-ordered this book
She pre-ordered this book
in June of last year.
June of last year.
So I could get the Walmart exclusive edition with the 2 specific bonus chapters. Each store had different bonus chapters. My friend Emily got the Target version. Her friend got the Amazon version, and then my friend Kelsey got the Barnes & Noble version.
Oh my God. Let me read some of these reviews.
I'm so scared. I'm so scared.
Tender, funny, hot, and satisfying. This is definitely a fairy porn book. Let's flip open to a chapter, shall we? Oh, let's see here. Let's if there's anything spicy in here.
There really
this
wasn't
is definitely fairy porn.
There.
Is it fairy porn?
No.
There's no smut in this book.
No, there's some smut.
Yeah, that's what I'm saying.
But they're not fairies. They're shifters. It's
Oh,
different.
shifter porn. Excuse me, chat.
Okay. Anyways, I ordered the Walmart exclusive to get the bonus chapters, and they didn't send me the bonus chapters.
Well, why don't you take it up with the Walden family?
I did, and they sent me my money back. But guess what? They're out of
The extra chapters.
the bonus chapters.
Well, I don't know what to tell you.
I am so upset. I had one job in my friend group, and it was to get the Walmart.
You should never
bonus
trust
chapters.
Walmart. Walmart's trash.
Well, listen, we had to, okay? They had 2 chapters.
Okay. Well,
That's all.
you could probably pirate it.
I know, it's probably somewhere online. But I paid good money for it. And also, the book is now on sale at Walmart for $22, and I bought it for $31. And that's bullshit.
Your credit card probably has price protection.
I mean, I got a full refund from the Walmart family.
Your credit card company doesn't know that. Unless you paid for it on that credit card.
I might have.
Now that you work for the Triangle Company, what's going to happen to OCaml? We're going to write OCaml in the mornings, and we're going to try to convince people that OCaml is the fastest and most efficient way to render React on the server. Okay, so we've got our skip.
Okay, sorry. One more thing.
One more thing? Okay.
One more thing. This doesn't pertain to me. Contractor Wednesday.
Wednesday
Just texted me back. Yeah.
morning.
Yeah, he said to have tape and stuff ready to go
All right.
Wednesday.
Well, I'll mark this when I paint the ceiling again here in a bit. I'll start marking.
Okay.
Will you come mark too with the spots you hate?
I'm
Cool.
gonna go play Baldur's Gate. Bye.
Okay, have fun on Baldur's Gate.
Thanks, I will.
Zaka asked, I've done C, C++, Rust non-professionally. Should I start learning web dev / backend? I feel like only other option is game dev with C++. I think learning web dev in general, or how at least the web dev world works as far as like infra and what that space looks like, is valuable. I don't think it would hurt. What up, robot? All right, so we got our skip white space, blah, blah, blah. Great, great, great. This all looks good. We have our test. All right, what was the next part of this book? All right, we need to parse our keywords into identifiers. So we need to be able to map a string to an identifier. So let's write that function. So we can work over here. So we want let keyword of string And this will be a function that matches on read will be read, and I do herd camels every morning. Well, I haven't been great. My consistency on streaming hasn't been great in the month of January because of a handful of dentist appointments, contractors just not getting their shit together on doing renovations, and interviewing constantly and being exhausted from that. But generally, I stream from 7 a.m. to 10 a.m. Eastern time doing OCaml. So that's when I herd OCamls. Although we might be moving our stream time 6 a.m. to 9 a.m. depending on where the majority of my team lives and works from when I start at Vercel. We'll say stir, legal, and this will be stir. Great. I wonder if we should raise on that. Actually, let's see how and if TJ implemented this. I don't want that. Hold on, chat. We don't need that. We don't need that. All right. How did he implement skip whitespace? He takes a lexer. Okay. He has a seek function that takes the lexer and a callback. That's clever. That's a great idea. I'm going to steal that. We're going to implement seek. So let's say right here, let seek is going to take our lexer and a callback. Or maybe that's a predicate. And we're going to say match lexer.character with, we say predicate How did he use that in whitespace? I don't want to look at the actual implementation of seek because I kind of want to figure it out myself. Let's see here. Where's whitespace? Skip whitespace. Seek. We get the character. So it keeps advancing the lexer inside of seek. All right, let's think about what this does here. So this is returning a lexer and possibly a token or a character. The callback gets a character, so we can at least do that. So at the very least, the bare minimum, it would be, I'm not even sure this is a skip whitespace. Yeah, it is a predicate. Okay. So it would be predicate lexer into lexer.character into predicate. And this should be a lexer callback that takes a character that returns a boolean. Right. Right. Okay. So that's a good start. So we're trying to implement seek based on how this works here. So I'm assuming this returns a token. So I think like the actual definition of seek would be something like val seek would be a lexer.t and then a function that takes a char to a bool and then returns, let's close this side, and it returns a tuple where it's going to be our lexer and a character. I think that's what we want to effectively implement with seek. Does that seem right? Yeah, Leo, I don't know if I told you this earlier, or I know a bunch of people in my chat might appreciate or find this humorous, but I was interviewing for a Haskell job. And as far as I know, my implementation essentially met like the criteria to pass. My feedback on why I was rejected as a candidate for a Haskell job, mind you, was that I spent too much time considering the types and designing types for my solution. Now, I spent maybe 15 minutes tops of a 2 to 3 hour interview designing types, and my types, for those who know TypeScript, all I did was wrote some Zod parsers to parse some JSON. Like that was like essentially the extent of my types. It's not like I went buck wild or anything with types. But I got rejected, and my only feedback was that I spent too much time considering types. And it was a take home, so it's not even like they were with me the whole time, but I got to go over my solution for an hour, and I never got any sort of feedback that my solution was bad or poor, or that I spent too much time on types. It was wild. So I'm not convinced that's the real reason, but that is a strange reason for a Haskell shop to reject a candidate, I think. Right? Like I could have went even harder and really modeled the type system to not allow any invalid states. My favorite article was shared with me by Alice, actually, that I've read in like the past year. Let me see if I can find it. This is such a good article. Types as axioms. Yeah, this article here. We're playing God with static types. This article is so good, regardless if you're a C programmer, a C++ programmer, an Alexa programmer. Like, this article is so good, especially if you're a TypeScript dev. It will really highlight why there are better type systems out there. I love this article so much. Typing 342, typing the technical interview. This will be on the read list. Looks like a deck of cards, maybe? Yeah. I thought that was a wild reason to get rejected from a Haskell job, was for considering types too strongly. But I digress. Ryan said, I feel that for an Alexa job, the take-home work, I wrote some dope code and they didn't like it. I was actually proud of it, and that's why they reject me. Yeah, I've had that happen before, too. I used Next.js when it was like brand new. Not brand new. Like Next would have been out. This would have been like 2017, 2017. In fact, it was NPM. NPM rejected me for using Next.js in an interview because they didn't know what it was at that point. The interviewer didn't know what Next was and was like, nah, dog, this ain't it. In retrospect, all the shit that went down from like 2018, 2019 to like the early 2021, like NPM was a shit show for a while. So retrospect, glad I didn't work there, but man, that would have been fun for a bit. I had to explain Docker to Cisco in an interview. Nice. What up, Dota? Yeah, I agree with Leo. Okay, so let's finish implementing this. Let's annotate these. So this is going to be a T. This is going to be a function that goes from chartable and we're going to return a T. Oh, maybe we return a token option. I bet that's what TJ returns. Oh man, we're just getting raided left and right, y'all. Thank you for the raid, Adam. How was stream? What were you working on? Chat, make sure y'all go follow Adam. Yes, I was on CM Griffing's stream. I stream with Chris on Tuesdays. Try to be consistent, but my life has been a little bit of flux the past month. I'm not mad that I was just identified by my keyboard. Expression is type char option, but an expression was expected of type char. Ah, right. This should be a char option. Well, in fact, probably want it just to be a char, right? So we'll say we'll match on lexer.character with, and then we'll say if it's a none, none, we're just going to return our lexer and a none. Otherwise, if it's a sum, we'll get a character, and we'll say lexer predicate character. Oh, right. Right. All right, let's look at this again. I appreciate that, Adam. That's hilarious. So we, Raiders, what we were working on is we're working on writing a tiny little lexer and parser for a tiny programming language called rint. The grammar for rint is right here. And rint is the first programming language that we write a compiler for in the book called Essentials of Compilation, which is free and you can find here. We have a little book club going in our Discord where every Sunday we get together for an hour and do one chapter at a time. The book doesn't have anything about parsers or lexers and basically just starts you off with like the AST. I've never implemented a lexer or parser really, so I wanted to take the time to try to learn how to do that. So as a means for learning that, we are skimming and reading through Thorsten Ball's book, Writing an Interpreter in Go, translating it to OCaml, and also taking some inspiration from TJ DeVries as he read through this book and implemented it in OCaml. So that's kind of what we're doing now. Let's see here. I can see the JS doc movement over TS, said Pick. TypeScript's inference is pretty doo-doo. That's true. That is true. TypeScript's inference is actually dog water. I feel like this should be a simple inference, but TS gets so lost. Sorry, Pick. I feel like this is a... I cannot even imagine if TypeScript wasn't your first statically typed language. Like, okay, let me revise that to say, if C++, Java, or TypeScript weren't your first statically typed languages, and you had to go to TypeScript from a language that had really good type inference and a really solid type system like OCaml or Gleam or Haskell, like, it would be so frustrating learning TypeScript. And my chat will know that I have a love-hate relationship with TypeScript. I think TypeScript has done a world of good for web dev, but at the same time, its type system leaves a lot to be desired. Okay, so let's jump back into Thorsten's book here. We've got our white space parsing. Right, we need to do our identifier lookup. I'm getting so distracted. I have a hate-hate relationship. That's fair. That's fair. I do think some positive things have come from TypeScript. It's better than a decade ago when we were all writing our web apps in just Angular and raw JavaScript. Okay, so we did do this. Right, I wanted to go see how TJ did this little lookup, if he did it at all. And I got distracted by raids and everything else. Do we have another thing open here? I must have just closed the repo by accident. Is it not in here? I'm trying to remember the name of... Thanks, Adam. Appreciate you raiding and stopping by. Have a lovely day or evening wherever you may be. And yeah, chat, make sure you go follow Adam. Where the heck is the repo from Prime? I'm never gonna find this. I'm never gonna find it. I've lost it. All right, we gotta go back to Prime's GitHub. TS Rust, here we go, this is it. Okay, we found it. Back to, does he have a token file? He does, okay. So does he have a, yes, okay. Lookup identifier, and we have keyword of string. So maybe a better name would be, how does he do this? So he has ident. And here, What up, monkey? Idents may turn into keyword tokens. Okay, so then we'll do, instead of illegal, we'll say identifier string. And let's leave a comment here. To do revisit whether this should be identifier, stir, or illegal string. So that's good for now, since we only have 2 reserved words in this language. Okay, so we have that. Great. And there's no errors there. Read keyword. Okay. I can get on board with that for now. Where's my error in here? Expression is type bool, but right, we have to map this to a token T option. What up, Boic? We are parsing a tiny little programming language. I feel like I've given the spiel so we're working, there's a little book club in our Discord going on right now. We're reading Essentials of Compilation. I know, I need to set up today commands. We're reading through Essentials of Compilation, and in chapter 1, we build a compiler for this tiny programming language called rint, which the grammar is super simple. We have 4 forms of expressions, and that makes up the entire language, with a terminal node called program. So we have integers, we have a read, which evaluates to a integer. We have negation, and we have addition. Very simple. The book, as you work through the chapters, as I understand it, essentially just hands you the AST for the language. And given that I've never really written many lexers or parsers, I wanted to, it started yesterday. So we do it Sundays at 1 p.m. EST. Yeah, so feel free to jump in. The book's free. It's written assuming you're using Racket to parse basically Racket, but I am using OCaml. Prophet is using Scala. We have someone using C. We've got someone using Rust. So we've kind of got people implementing this book kind of across the board with different languages. Yeah, we only did chapter 1. Next Sunday is going to be chapter 2. So the first chapter is really light, and it's really digestible too. It's written really well. I've already taken value from the first chapter, so. Yeah, yep, exactly. And if you join, there's a channel in our Discord. What in good God is this? That might be the most cursed image I've seen in a while. Good God. There is a channel called Reading Rainbow, and that's kind of where the book club stuff is. So feel free to hop in there. All right. So I still want to go look at TJ's seek function in the white space. Skip white space. I don't want to spoil the full implementation, so I'm assuming this is a token option. Let's see if we can see seek anywhere else down here. Seek, 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 no. Seek, read, no. I don't want to look at the implementation. There was the implementation. Do we think that seek returns a token or a character? Because it's definitely advancing the lexer. So that's one thing we have to do is advance the lexer, right? So let's break this down to 2 lines again. So if we get some character, when predicate character equals true, we advance the lexer. Advance lexer. And maybe let's first now return our just a character. Otherwise we return lexer some character. This probably needs to be recursive, I bet. Lexer predicate equals true. Let's type bool. That's a char, first of all. That's a char. Oh, right, because this one's a token right now. This needs to be a char for now. And what is this error? I guess we just do, this might be a Jane Street thing. So bool dot equal, and we'll say predicate, probably needs to be in parens, predicate char and true. Yeah, there we go. I'm not sure if that's 100% correct. What up, Antonio? One of these times, you're going to preemptively say rigged, and you're actually going to win. Rip. All right, I'm running the bathroom quick. I will be right back. Okay. And we're back. So that was a long ad break. You could use your Amazon Prime, if you have Amazon Prime, to avoid ads. Let's see here. Seek. So can we use our current implementation of Seek to get us through skip white space? Because if we look at Teach's implementation, he basically says, let's just write a skip v2, and we'll say, I don't care if you backseat, that's fine. I'm gonna learn something regardless. Seek will take our lexer, and then this is going to take our callback, which is going to be, we're going to get a character, and we're going to say, right, we'll say, actually we can just do function, sum. Can I do this in a lambda? And we'll just say anything else returns a none too, just to test if we can do this. Seek, what we take? We get our function, and then we get back, let's just say we return the lexer. Right, because we're gonna get a right, it has to return false. How am I not getting type errors here? Right, that actually makes sense. Okay, so I can't do that. I've never written incorrect code in my life. So this will be so I wonder why he used an option. Doesn't feel like we need to use an option. Technically, I think we could be like, why can I think we could say is white space, right? Something like that. And now we'll just advance the lexer. Although this is not recursive, so I think in this case, we have to call, in fact, we can ignore that, right? we say we need to make this recursive. And then we say seek, and then our advancer will be advanced, the lexer. Our predicate is the same. Yeah, I think that might be right. So if the lexer's character is none, we've probably hit the end of the file, or it's an empty string for our input. Otherwise, we parse a character and we check if it's the character we want. If it is, we advance the lexer and we return a tuple with the lexer and an option of sum with the character. Otherwise, we recurse and we recall seek and we move the lexer forward and continue seeking for the character we're looking for. I feel like a better name for this would be seek char rather than just seek. We could make it polymorphic. Nah, seek char is fine. So theoretically, let's rename this v2, and we have a test down here. We could drop in, let's make sure our test suite is still building. Doom build, and let's run Dune run test. Okay, so we're failing, but we didn't really change anything. I actually don't know why we're failing. So we didn't touch the normal weight space at all. So what test failed is white space. So why is that failing? Which one of these prints the... Same as f print f. Is that what I want? Do I get FMT here? No, I don't. How do I print with base? Print f dot. Sure. It's the most confusing type I've ever read. Is that all it needs is a unit? The types are so broken with base right now. Oh, so I must already have FMT? Okay, I'll take that. What? So we've got FMT, right? All right, so we get a lexer, and then we loop over the lexer, and we match the current character when it's a sum, and the character is white space. We advance the lexer, and then we pass it to loop. Otherwise, we have some character, right? And we return the lexer. See you, Leah. Catch you in the morning. Sleep well, homie. I actually don't know why this isn't working. Thank you for the follow, John Techie. Appreciate you. So we're failing on when we parse the option, which is, where's that at? Right here. We advance it. And what does next token do? Next token takes our lexer, and we just grab the current token. So we advance the lexer, we get some token. I don't see a issue here, to be honest. Well, if we just drop in our second implementation with the seek function, I wonder if that would work. Probably not. Yeah, we're still failing. Line 88. Great. That gives us a lot of information. Line 62. Yeah, okay, that's our actual test. Did we change something in token that threw something off? We did add this keyword as string, but that doesn't do anything yet. I can't understand. I can't understand why this is failing. Okay, so yeah. To string. Okay, let's see what that says here. We got an end of file. So what happens if we delete this guy? We do something like that. No, that's not gonna work. All right, so we skip. It's so confusing. Let's make sure we still get end of file there. Okay, we're not even getting here because this is raising. This is not... Why? So we hit loop. Lexer.character is... When we make a lexer, what happens? If it's greater than 0, we say position is 0. We get the first character. That's a white space. So... This should return true. We get our Lexer. We pass it to advance. We take our Lexer. We take its position. Increments it to 1. Is it greater than or equal to the length? It is not. So we fall into here. We get our new position. We grab the next character. Okay, that looks good. Then we pass it to next token. Next token looks at the current character at the current position that we're looking at. It's not going to be none. It's going to be a white space. So it goes to end of file. That's the issue. Right. Okay. Although that doesn't make complete sense, right? Because if we're... Because we're recursively looping through until we hit a character that's not a white space. And we should hit the plus sign. And when we hit the plus sign, we return back the Lexer. So when we get here, the Lexer state should be position. Let's yank the position. Let's actually make this easier to debug, and we'll just do one white space, right? So now we have one white space and a plus sign. Okay, so we should be able to say that, let's write a test here that says, Lexer.position equals 1. And we'll comment those. And we'll do a June run test. So that failed. That's interesting. What does it think it is? What up, Dev Dad? Thank you for the cheer of 100 bits. Appreciate you as always. Let's say position is, yeah. And then we'll say, let's start with input actually. So input will be a string %s, and we'll have a new line there. We have position, and then we have char, which I don't know if I can do %c if that's even valid. And this ends up turning into input, which will be, yeah. All right, let's see what that spits out. Nothing, because it raises an exception when we get to here. Do I not have diagnostics on? Okay, so maybe, so our input is correct. Our position is 0. So we never actually advanced. How do we have this test passing earlier and now it's broken? Oh, because we're looking at an old version of the Lexer. Right. Right. That makes sense why we're getting bad logging there. This is going to be a Lexer and token opt. Right? Yeah. And we can shadow that. So let's try looking at that now. This is way too heavy. I don't like this. There we go. This is a chill song. Let's see. Position is 1. Right, so this needs to actually be like, so char is none. Let's convert this to a string, and then we'll say char.toString. Pass that in there, and we'll just add that. And this will be none. And let's wrap this in parens. Right. I guess we have to do a map here, right? Option dot map. That probably takes an F. Yep. F is going to be char dot toString. There we go. So somehow when we call so we get the plus. What up, trash puppy? So when we advance the Lexer, we're now looking at the plus, right? And this returns us the Lexer. And if we do next token, I would expect we have a token option here, right? And we should be able to assert something stupid like option dot value exception token opt, and then we can pass that into token equal expected, and it should be add. This test should pass. Okay, passes. That's what I would expect. So now why can we not do skip white space and have this pass? It does pass. What? What? Oh, I was advancing after the white space, which we didn't need to do. Stupid, stupid, stupid. Chat. Skill issues galore. So now, this should just be our token. And we can get rid of this junk. Delete, fine, there. Expected. We'll say this will be actual. And this test should still pass. First try. Everyone saw me do it on the first try. All right, everyone saw it. Okay, so our skip white space original is working. Let's see if our skip white space v2 is also working. Using the seek function. It does work, great. So we can delete our old, let's comment it to start. I'm curious if TJ's implementation returns a token. Because if we look here, do we have any way toString? We don't have an of string. We have our next token bit. Do we think that TJ's implementation of seek is seek token or seek char? I think this is seek char. Like, I think it makes sense to seek for. Let's find out. All right, seek is, where is it at? Right here. Takes a lexer and a condition, which we're doing the same thing. We do a recursive loop. If, all right, he's using if statements and we're using a match. So if that's truthy, I guess. Yeah, if the predicate returns true, that's different than what we're doing actually. He advances the lexer. Oh, he returns a position. Why would you need to do that? Because this lexer has the position on it. Is seek exposed in the MLI? It's not. I'm not sure that makes a ton of sense to return the position. Because you can just pluck it off the lexer, right? Because you advance it. Yeah. So I don't even think we need to return. Yeah, I don't think we need to return the option. We can just return the lexer. Okay, that looks good there. So his predicate must deal with, yeah, we kind of just inverted things, right? So his predicate must, the type of this must be a function that takes a character option where our predicate just takes a character. And we don't do anything if it's a none. But maybe it does make sense to put that on the caller, right? I kind of actually like that. That makes it more flexible. F sharp and OCaml are super similar. So I would say that OCaml is to Java as F sharp is to C sharp. Yeah, F sharp is gonna feel. F sharp is basically inspired by OCaml. Okay, so that simplifies that. That puts it on the caller. So this becomes it's gonna become like option.map. Does everyone see this error message right now? This expression has type char option to bool. It goes to bool option. Never mind. Disregard. So this will be function, and we're gonna get char option, and this will go. Wait, so why use OCaml over F sharp? Isn't having .NET more useful? I find the OCaml ecosystem closer to this. Like, I don't use a lot of .NET. Yeah, I've actually never really written any F sharp. I'm sure F sharp is great, but I've never really used it. So we can do like option dot value map. Takes an option, a default. Maybe it's fold. I think it's map, really. It needs to return a Boolean. Right. So we say, really, this can just be a function, and we can match on none will be false, and some char is white space char, right? That's still... takes Alexa, returns Alexa. Okay, I think that's what we want. In fact, this can be option.fold, I think. On none returns init, on sum x returns f init x. I think it's fold. What does apply do? A function where we get a to b. No, that's not what we want. Value. No, that still won't work. Well, we could. No, we want fold. So let's go back and do some parens, and we'll do option.fold. And our init will be, let's see here. On none returns init, so that will be false. And then fold takes a function, which probably is, yeah, labeled with f. And that's going to take fun, our accumulator, and our value, which will be a character. And we have a function, f init x. We say is white space char. Yeah, there we go. Let's run our tests. Right. Boom. Great. All right, so we've got that working. We have an implementation of seek, which is really seek char, right? Or really, this is like seek until. Or even more, a better name would be advance until. So what we're saying here, let's fix this up a little bit. Yeah, so what we're saying is we take Alexa and we're going to advance until a character is, this is actually advance while, not advance until. Right? Yeah, so we continue advancing the lexer while our predicate is true. That makes a lot of sense. We can write a test for that. So let's write a test. So let percent test underscore module, and we'll say advance while equals, and let's say let input is going to be Oops, that's not right. We need to say module, and then we'll write a test, and we'll say let %test, and we're testing it should advance while the predicate function is true. And this will be that, and we'll say we have let input, we'll have a bunch of pluses, and then like a minus, right? And we'll put a plus there, just for shits and giggles. In fact, we'll just put a paren. And then we'll make our lexer. So our lexer is going to be make input in. And then we'll say let advanced lexer is going to be advance while. And this will we'll pipe our lexer into that. And our function will be, it takes a char, and we'll say token, we'll just say char dot equal, which I'm sure is in, yep, char, and we'll say that is plus. Is this an option? Right, so we want to do this is annoying dealing with options. I don't know if I like does it make sense to expose the option to the caller? I don't think it makes sense to expose the option. I kind of like our original implementation, right? Because like you can't advance the lexer if the character is none. Like it just can't happen. So this makes, I don't think this makes a ton of sense. So we should probably go back to our original implementation where it was like we match on lexer.character. If it's a none, we just return our lexer. If it's a sum, and then we'll get a character. When predicate, yeah. We'll take our lexer, we'll pipe it into advance. Yeah, that looks good. And our final one will be our sum char. And we just return the lexer. Is that right? Which means we can actually simplify this. And this will be, yeah, it'll be that. And then we can simplify our predicate, right? Because now our predicate just becomes is white space, which is much nicer. Chartable, which is right. This expression is type, oh, it's that, there we go. Okay. We should be able to say let tokens equals lex string.get advanced lexer.position. And this probably has to be the second argument. String int, and Lex takes a string, returns a token list. So what's wrong with this? Oh, this needs to be changed around that to that. Okay, there's one problem. Expression is type char, but an expression was expected of type string. So maybe string.get's not the right function we want. String.from. Nope. From. Is there a slice? No. What do you got in here? Suffix sn returns the longest suffix of s. I don't think that's it. Just want like a slice. Index from. So we take it's a function that takes a string, an integer, a character, and then returns an int option. That's not it. Oh, I bet substring's it, right? I bet there's a substring function. Sub. Thank you for the follow, Big Kano. Appreciate you. Substring search and replace. That's not what we want to do. I want like a from or something. All right, let's ask OCaml Genie. Does Jane Street base have a substring slash slice slash splice method? I want to grab a string. I want to create a new string starting at index x to the end of the string. Subfunction. Sub s. Is that true? String dot sub. All right, so it's saying we pass it a string. So that'll be our advanced lexer. Let's just override this. Right, so we do that, and we say we're going to pass it our lexer, and it wants a position, and that'll be our lexer position. Yeah, it'll be something like this. This will be input. String.length, right, this will be input. Sure. That is a terrible definition for that. Takes a position, an int. Sure, whatever. Okay. So let's actually make this that. Yeah. So we should say list.length tokens should equal 2. Right? Because we should advance up until there, then we should stop, and then we have these two here. And we should parse that to a negate and a right paren. So let's run test. Great, that looks good. Okay, that worked good. Can we do let this assert takes a unit. Whatever. So we want to say that let's call this actual. And then we'll say expected. Expected will be a list where it's going to be negate followed by right paren. And we can say token dot equal expected actual. List dot equal, right? List. Yeah, there we go. Great, that passed. Okay, so our advanced while function works exactly as expected. That's awesome. That's super awesome, actually. I think I might call it there, chat. It's getting a little late. I still have to do some painting, which is annoying. Yeah, let's find someone to raid, and we'll be back around 7 to 7:30 a.m. Eastern time tomorrow morning. And yeah, we're going to keep working on this tomorrow. And then on Wednesday, we're going to pair program with Leandro, or his Twitch username is Leostera. Same on Twitter. Highly recommend following. So make sure to check that out. We're going to be working on some Riot work, which for anyone unfamiliar, Riot is essentially a port of Erlang and Elixir's OTP runtime / framework to OCaml. So we got this really beautiful and amazing like actor concurrency framework. When is that Leo's collab? It'll probably be around 8 to 9 a.m. Eastern time on Wednesday. It will be, it will for sure be uploaded as a VOD, and we'll probably throw it on YouTube as a standalone clip. But yeah, that's when it'll be live. Also, the stuff I'm working on, chat, is for a book club that our Discord is doing. We're reading The Essentials of Compilation, which I know I've shared and said a couple times. If you're interested, we're very early. We're only done chapter 1. We meet Wednesdays. We meet Sundays on Discord at 1 p.m. Eastern time, and just go one chapter at a time. It's super fun. Right now, we've implemented a compiler in chapter 1 for a language called rint. Very, very simple, but it's a ton of fun. So yeah, check that out, and let's find someone to raid. Oh, we gotta raid Chris. I'll probably be streaming with CM Griffin tomorrow night, working on the OCaml Vexilla client as well. So let's go give CM Griffin some love. Thank you, y'all. We'll see you tomorrow morning, bright and early, or if not, whenever y'all manage to land back on stream. I appreciate all of y'all.